Can you all hear me well, especially guys in the back? All good? Thank you. Because everybody is happy after pizza, sleepy, I can understand this. But yeah, my name is Eugene. I currently work as senior software engineer with Speechify, which is an American startup doing different things around text-to-speech. And we're going to talk about signals today, but why did I come to this topic is, so the specific product that my team is working on is essentially a video editor in the browser. And if you're familiar with any kind of video or audio editors, it has a timeline. And a timeline has some movable things on it, like blocks. And there can be many of them, like 1,000 easily. And when you move them around, other blocks are pushed forward, and other blocks are pushed further forward, and they also need to maintain the gaps. And you can imagine, with the most naive implementation, there could be lots and lots of recalculations, and that's actually what is happening in version 1 of our product. And it's not great, because typically you don't want to send 1,000 updates to your entities, to the API, and also you can avoid that. And at the same time, on the client side, you don't want to re-render every single block, which would happen if you just hook everything to React state in the most naive way. So when we were going to design version 2, I was like, let's consider signals. Now, the full disclosure is I haven't used them before, but I was well aware of the idea. So I suggested my colleague who actually worked on the feature to consider them. And what I'm going to do today is I want you to understand the idea. I don't want you to buy it. I'm not selling you anything. Because I can understand that anybody who's been working front-end for years, 3+ at least, you've been through different state managers, especially if you're not working with a framework like Angular, that's better is included. And if you work with React, most likely you went through Redux and something else, and Zustand, and maybe Jotai. Jotai is actually signals-based. And there are also 20+ alternative solutions around there. So you may be not very tempted to learn yet another one. So what's good about signals? Twofold, but one is that it's an idea. It's also not a new one. It dates back to 60s, early 70s maybe. Because many things in front end, they're not invented. They're just applied, the old ideas from some established and more boring and less dynamic maybe environments, already completely developed in the 70s. They do apply, because ideas are valuable. And if you know the idea, you can later pin your facts to this idea and make the connections. So signals in general, they're a way to maintain reactivity of data. And they're not a specific library. There are multiple implementations. Some are built into some frameworks like Svelte version 5. And some are standalone. But I'm going to try to make you understand the idea. Now, also, I've mentioned some background, but I'm not going to talk about the history of signals and their specific implementations across frameworks. But if you happen to be a digit in TAR2 in May, come and I'll be talking about all of that there. So I'll have another talk, different from this one, more theoretical, more entry-level, but also with some anecdotes from our actual experience. So what is a signal? I proudly present to you this. I've actually drawn it by myself, no AI. So what is that? That's a box. Or at least that's my idea how the box, without a lamp inside, just a box, looks. So those who work with, I know, C++, Java, Rust, many different languages, you know the idea of boxing. So you create an object that contains something else. What is an advantage of a box is that the box itself never changes. Like you create it and you can put the value inside and you can read the value from it. So that's a signal. Not that much, right? So if that would be the entire idea of signals, probably I wouldn't be taking your time. But let's see some code, specific code. And I've said that signals are not a specific library, but of course there are specific implementations of them. And one of these implementations comes from the Preact framework. Somebody aware of this framework? A bit of lesser known, but it's a good and fast alternative to React that drops all backward compatibility. But there are signals implementation standalone. You don't have to code in Preact. You can use it with anything, including with React. Also, it's quite small. Like the entire implementation of the core is about 800 lines of code, not much, for what I'm going to show you. But yes, we've seen two basic operations: put the value in, get it back. With Preact signals, it looks like this. So signal is a factory that wraps any value. It does not have to be primitive. They work the best in my experience with primitives, but also work well with arrays or dictionaries. And you can put anything inside it. You can override the value, and you can read it back. That's it. So this is not very useful, right? It's not also reactive, but signals are reactive. So what they let you do as the next thing is you can subscribe to changes, which would be like this. Also not very exciting, but now we can react to the updates. So that's something. That's not much, because imagine you have two different signals. One of them can change or the other can change, and you need to react to these changes. So you would have two subscriptions probably calling the same method to react to these two new values. That's bad developer experience. So this is just last resort, and that's a basic building block. But what signals let you do, and that's where the magic starts, you can combine multiple signals into the new value. And if you work in front end, in my experience and in my opinion, computed state or derived data, or call it any way you want, it's a serious issue if your application is of large scale and you don't know how to manage it. Like with pure React hooks, just built in, have plenty of use callbacks and use memos all over your code, and then it's a bit hard to find where your business logic is. You can do that. You can do that ultimately. Like everything you can do with signals, you can do without them. But the point is, in my opinion, it's much more straightforward. So they're just a tiny, smallish wrapper around plain values. Whenever you would use a plain value, but you need reactivity, you wrap it in a signal. So how does it look to combine two signals into something else? It looks like this. So there is another helper method called computed. Inside you can have arbitrary logic, anything that is synchronous. And whatever you return becomes the value of u in this example. And whenever any signal that's being read inside of this computed callback changes, the callback is called again, and the new value is put into the computed signal. So this is the core idea of this entire signal saga. And it can get you real far, honestly. Because you can have conditionals, you can have loops, whatever, because it tracks whatever was read in the last run, and only that change can influence the necessity to run it again. And if that has changed, let's say you have a signal in an if condition, then under it, in two different branches, you can read different signals too, and it will subscribe to them. And whenever that changes, it will recalculate the value again. So adding up two values is not much, but one of the most straightforward applications would be you have a search and you need to filter an array of entries. So you do that. And now you get a signal with this filtered array. You don't need to think about it anymore. And this callback is the closest to declarative that we can get while still working with imperative code. Okay, what else you can do is you can also subscribe to multiple signals and react to that without computing things. That's called an effect. That's also extremely straightforward. It's basically the same API, it just doesn't return anything. So this will log the sum of these two values whenever any of them changes. You can do more interesting things with that. For example, a class represents a book. It can be updated. The title, the author, the ISBN number. Whenever any of these properties is updated, we want to track the time when the entity as a whole was updated. So we do this and we forget about it. And we do not litter our business logic with a small consideration, and we don't need to repeat it everywhere. So we are actually doing that for tracking updates to our blocks on the timeline, and we don't need to think about every single place where it can update. We just need to be aware of all the attributes that can influence this. Finally, two more things before we're going to look at some more real-world code. Sometimes you want to see the value without subscribing to it. Similar to how you can have a stack, you can pop a value, or you can just pick at it what is there at the tip of the stack. Same method, pick, just returns the value, no subscription. Useful sometimes. And you can also batch updates. That's quite important. So you can batch multiple signal writes, as many as you need, and that will be an atomic change in terms of changes propagation. So only after both of these writes happen, all the computed signals dependent on either V1, V2, or both will be recomputed. And that way you can also hook more effects to them, like sending the call to persistence layer and saving things. So you move several blocks together in our example, and we batch this operation. What we can also do, it's now trivial to undo this operation, because we only need to track which signals were updated, from what value, and to which one, and the undo is just assigning the old value back, and that's it. And finally, if you work with React specifically, basically the strawman, the only thing that you need to make your components reactive to signals is a single hook called useSignals. So you put it at the top of your component, and whenever this component, but none of the children are considered, only this component itself, when it reads from some signals, it subscribes to the changes. And when some of the signals changes, the component will re-render. It works for plain signals, it works for computed signals. They're uniform. You don't need to think about it. We're masking some real signals as read-only in our code because the consumers don't need to write to them, and to the consumer it's all transparent. So that's 101. That's 101. The final thing is, if you work with React, you use the core library for signals themselves, and you use the signals React library for the specific hook useSignals. So that's it, but I want you to see some real code. And it's a bit hefty to do it with one hand, but let me just crack it up. I have a question. Who knows what a file is? File, anybody? Folder, you know about that? Because I've heard people these days are not aware of files and folders, yet alone file systems. But you have IDEs and you have this funny icons there. They correspond to files. There are some names next to them. So I've mocked that. Let's see how it works. It's quite straightforward, not accessible. We have this icon-only buttons, only seen on hover. But you can create some folders and more folders, and you can create some files and more files. So every folder and every file has a name, and every file has its own size, randomly generated. And the size of the folder, we agree that it's computed like the sum of the sizes of all the items inside of it, plus 4 kilobytes. That's roughly how FAT32 works, I think. It doesn't matter. What matters is that we need to run some computations, and by their nature, they're recursive. And if you hear recursion coupled with your UI, you should be slightly cautious. And I'll show that. But before that, let's check what the application is about altogether. Should I make it larger? Is that better? Cool. So I'll show you 6 files, explain what's happening there. You don't need to read every line. I just want you to understand what I did there. So let's start with types. A base node is a generalization of a file or a folder, so we know it can have a name, it should have a name. It has some internal ID, and it can have an ID of the parent folder. A file is a specific node. It also has the size as its natural property, and it definitely belongs to a folder. It cannot be nowhere. Now, I'm also using the thing called brand types to differentiate between these types and TypeScript. This is non-essential. This is just, it makes code nicer. A folder, similarly, it doesn't have the size naturally. The size is computed. I've defined the rule. It's the sum of all the elements inside, the size of them, plus 4 kilobytes on top of that. It has children IDs, so it's doubly linked tree, and it has a parent ID. And there is a special case for root. So root has special ID, and it doesn't have a parent. And for the rest, it's similar to a folder. And then there is a file system, which is just a catalog of all the nodes, mapping the ID to the specific node. So that's our domain. Now I have some factories here. They're just methods to declaratively or in a more approachable way build the entities. So we have makefile, linking to parent ID, getting some random ID, a random name, and random size. Make folder, similarly, parent ID, random own ID, random name, empty array of children. And make root, same stuff. Fixed name, fixed ID, no parent, empty array of children. And make file system, for file system starts with the root, and originally that's the only item in the catalog. Now I have two file size related utils, actually item size related utils. One is just to format stuff, and the other is this business rule, the business logic that I've described, how we calculate the size of the folder. 4K plus the sum of the sizes of everything inside. And that will be called recursively as we go deeper. Now, this original application that I'm showing you is written in React without any external libraries other than Immer, which I will describe briefly. So our entire state must be immutable, which means every time we add an item or we remove an item, we need to rebuild the entire state, like the entire file system, keeping every untouched object referentially the same, and updating or recreating the objects that were changed. Like imagine we create a file, so that's a new object. Then because this file's parent folder's list of children has changed, that has to be recreated and all the way to the top. So that's essentially what's done here, add item and delete item. Add item is quite straightforward. We find the parent, we build a new item, we register it with the file system, and we also add it to the list of the parent's children. Now the only fancy thing here is called produce, a method from Immer. It's just a helper library that makes your life easier as you need to rebuild immutable large structures because it gives you imperative like API, but behind the scenes what's happening here, I'm kind of mutating the object, but I'm touching the proxy. Afterwards, it rebuilds the original object the way you would do it by hand, just easier. Delete item is very similar. Check that the item is there. We can delete the root item, find the parent. The parent cannot be a file. Make sure the item is a children of its parent. Remove it from the parent children list and delete it from the file system. That's it. And now I have three components, very simple React components. One is called node presentation. It's a generic component that can either render a folder or a file. They're completely dumb. They have no idea about state or anything. They're pure representation. They accept all the methods as properties and you decide how to pass them around. So to render any item, we find it in the file system. We do compute size, and because we understand that recursion is not great for your UIs, we use Mimo here. If the item is not found, do nothing. If the item is a file, render file presentation. If the item is a folder, we render folder presentation. Really nothing cool here. File presentation, that's what we see here. So it has an icon, the name, the size, and an action button to delete it. For the folder presentation, so that's it. For the folder presentation, it's a similar header row, icon, title, size computed in our case. So we pass it as a property. There is no logic in these components. And then we have three action buttons to create a subfolder, create a file, and delete the folder itself. And then recursively, we go over children IDs of this folder, and we render them with our node presentation. And we are almost done. So finally, the application itself, just wrap everything in use callback to avoid unnecessary re-renders, and render the root node using our node presentation. So that's the application. And now I'm going to show you how what it takes to rewrite it from React state management to signals. So once again, what are the traces of React here is that we use state to keep the file system, and we have to recreate the file system, ensuring immutability, because that's how React rendering works. Otherwise, it couldn't detect the changes. So I've prepared a diff rather than going through this live. And I'm going to guide you through the changes I've made. And then I'll show you that it works. And then I will make a very small change, showing how you can optimize performance with signals. And that'll be that. OK, let's start with types. So first thing that I consider is that actually every node has the size. For files, the size is a natural property. They have it. We cannot do anything. They just need to contain it. For folders, it is computed. The beauty of signals is that if I wrap the size in a signal, I can unify it as read-only signal. Nobody from outside is going to write to this property. So for every consumer, we can type this as read-only signal. So what is read-only signal? Obviously, it's a signal that you can only read from. What's the use of that? For example, computed signals. So for folders, you probably remember that we had these utils to calculate the size of the folder, which is 4 kilobytes plus the size of every item inside. And if there are more folders, we go deeper recursively. But let's imagine there is already this logic wrapped in a computed signal. Then we can just say, OK, either a file or a folder or a root of the file system, it has size. We just want to read from it for our rendering. That's it, right? Now, you can also see this fancy $sign here. Good old jQuery times. So it's just a convention. There is no runtime, no transpilation, nothing. We just adopted this convention. It makes it more obvious. You look at the component, and you see some dollar somewhere, and you know there is a signal. You don't have to do that. So because I've introduced the size to the base node, I don't need to define it on the file level. And then there is only one extra thing that has to be reactive, and that's the list of children of the folder. Either we create a new child or we delete something. We need to re-render that, which defines reactivity, which if you are thinking in signals means you need the signal there. What you're going to store, up to you. Your design can be different. For example, the tree can be presented completely differently. I'm not keeping a tree in memory as a tree. I'm keeping it as a catalog and only linking by IDs, which works better for the specific case, may not be for you. But once again, there is no rule what you would put inside of the signal, but there is a very clear hint if you need your UI to be reactive to this property, use signal. OK, so that's it. That's it. That's the only things that I've changed in the data model. Moved size to be a reactive property or signal on every node. We will see how to implement that. And make children IDs also a signal. So whenever we add to it or remove from it, change the value inside the signal, there is reactive re-rendering. OK, going forward. Size. I've just removed get size. It has moved to different place. Nothing else. Factories. That's the most interesting thing. So everything that we need to understand about this rewrite is happening here. The rest is just catering for it. So makefile, we agreed that now we want the size property to be a signal. So we wrap it up with a signal factory. And I've renamed it to $signal, to $size for convention reasons. And for folders, that's actually what's happening. So children IDs, once again, I've explained why it has to be reactive, so it has to be wrapped in a signal. Inside is the same array of strings. So that's it. The signal, it's generic method, so I can pass in the type hint and initialize it with an empty array. And this is the most interesting thing. $size is a property that I've defined on this object that I'm returning from the factory. And the value for it is a signal that's being built with the computed method. So if you probably remember, we've seen an extremely contrived example of it right here. And that's how it works. Now, what I love about it is that this code is essentially the same code that used to be in our utilities, or if you want, in our business logic. And the only changes here are that some things are now signals, so you need to read from them by doing .value. So if we look at this, that's what it used to be. Return 4,000 plus children IDs mapped to get size and reduced to have a sum of them. And that's essentially the same thing happening here. The only difference is I need to get the child directly from the file system by ID. There is no reactive code here. And I need to read its value of the $size property. And what is happening here is that I don't need use memo anymore, because signals do memoize your computations by definition. If I read from the file $size .value, this signal never changes, so it will just give me the value that was there originally. But if I read from folder $size .value, that's a computed signal that's been already pre-computed for us, and it will be recomputed if some of its dependencies changes. Now, if you look at these dependencies, they're right here. And that's why we find it useful to have this $ prefix. So we read from self.$children IDs, which means whenever I create a new item inside or I remove it, this signal will be recomputed. And we also do read from item.$size .value, which means if, for instance, we would override the size of the file, everything up by the tree will recompute. Or if we delete an item, for example, in some folder, all of its parent folders will have their sizes recomputed for us without us writing this wiring logic. And the same is happening to make root. Make root is just a special case for a folder, so there is exactly the same logic here. And because I need to pass the reference to file system to make root and make folder, I had to slightly change the logic of the makeFS method, but it's not essential. It's just that I first create an empty file system, pass it to make root, and then register this root with file system. But there is no reactivity here. So if you think about it, what we're going to see now is that we don't need to rebuild the file system anymore. We just need to change the values inside of the signals. And the only place where we do it manually is the children IDs list for a folder. And that's it. The rest of the data stays untouched. There is more happening behind the scene without our intervention, and that's the calculations of the sizes, because we've defined them here as computed signal, and because we read from different signals inside, we will subscribe to them. Now, the rest of the changes are state management. I don't need immer anymore. I don't need to return the reconstructed file system. I just need to mutate things, like literally mutating them. So I've removed this return type. I removed this wrap it in produce, which was from immer to rebuild the entire file system structure. And rather, I just, what was that? That's not Windows. Don't do anything. Thank you. I create new item. This is a bit dirty div, but I hope you can understand what's going on. We used to mutate this draft coming from immer. Now we just register this new item with file system catalog, no reactivity there. This catalog is only needed to reference things. And there is reactivity here. We need to add it to the parent folders, children IDs, so we rebuild this array. Now, there is no way we would do anything else. The value inside of signal must referentially change to trigger this reactivity and re-rendering. So this is the same. That's old story. But we directly mutate the value inside the signal, and we'll subscribe to these changes in our component as it be it. For deleting an item, it's essentially the same. None of the logic here has changed. I check things, that's a valid parent, that's a valid item. The item is a child of its parent, apparently. So I use peek here, there's no reactivity, it's one-time check. And once again, I remove produce, I directly remove the item from the catalog, and I directly remove the item from the parent children IDs by filtering it out. Oh, it's a bit blurry there. Maybe that's better. So what's left? Presentation. Just to remind, we have 3 components to render a file, a folder, or either. These are all the changes I had to make to my presentation layer. For convenience, I've switched from ID to item. Actually, I don't think it's essential. I don't need to compute the size. So I removed this. I don't need to pass the size to the folder. It can read from its own data. And that's it. Now this one here is hidden. It's a file presentation. Rather than reading the size property, we do read $size.value. That's it. For folder, once again, we don't need to pass the size. The size is now part of our data model, magically recomputed by signals. We read it here. We similarly read from children IDs .value. And because this component has to be reactive, the file doesn't have to. We don't have file size changes, so the file component is essentially static. Now we need to make it reactive to signals by use signals. And that's it. Application level, yeah. So because we are not going to rebuild the file system, we don't need to keep it in a state. We can use Memo to just build it once. We could even create it at the module level in a separate module. Just import file system from file system.ts. That's it. If your application is purely client-side. If you need to delay this instantiation until client-side rendering, you better go with use Memo. If you don't need to do that, purely client-side or don't care about server-side, whatever is happening there, who cares, right? You can just have your state completely outside of React. So this is one of the things that are kind of paradigm shift. Your rendering layer, and React used to advertise itself as just a rendering library, can actually be just a rendering library. Your state does not belong to React. Your UI must react to your state. So signals give you this freedom. And also, worth mentioning is that they're not only not specific to any framework, they're also not specific to execution environment. They're very small and simple objects that can be run in any JavaScript-compatible runner. So you can run the same logic on server-side if you need. There is no limitations. There is nothing browser-specific, nothing Node.js specific. Just that. So you can run them in tests. That's what we do. It's super easy to cover them with unit tests because you just create some values, you mutate some values, and you check that the derived values have whatever must be there. That's it. There is no synchronization, no subscription. It all just recomputes when it has to, but never when it doesn't have to. So that's it. We don't need to update file system object. It's just there. So the rest here is simplified by not setting the new file system, just calling these methods from our domain, let's say, from our business logic layer, and letting them change the state. And we just need to react to it, which is the way the God has designed it. And that's it. OK, so let's actually make sure it works. I hope it works. And then I'll show how this application is not super performant and how we can improve that. So I'm running the equivalent application from different folder, the one that was obtained by applying this diff, or actually this diff was obtained from that folder. OK, looks good. Kind of works. Seems to work. So yeah, that's it. Same application, slightly less code, in my opinion, slightly more straightforward. You don't need to remember about recreating. You need to remember about different things, but they're closer to the metal, in my opinion. But you don't need to remember about recreating the entire state objects and setting them to trigger reactivity. You need to remember about subscribing with use signals, but that's it. What is good, in my opinion, once again, is that our algorithms, as I've mentioned, are as close to what they would do with normal variables as potentially possible, because JavaScript was not designed to have reactive variables. So this is the next best thing. You just put a signal there, and you assign to .value rather than to a normal variable, and that's kind of it. So if you take any algorithm from anywhere and you need to adapt it to cause reactive re-renderings, you need to consider which places are reactive or are sources of reactivity, and they must become signals. And you need to consider which places are derived data, and they must become computed signals. And no changes other than that would be needed for many algorithms. So what I wanted to show you, I'm going to drop a mic drop. There is this teeny tiny checkbox, also extremely blurry, in React DevTools that says highlight updates when components render. That's what React Scan is built around, essentially. Not exactly, but they're built on the same foundation. So you can use React Scanner, you can use that. This one is a bit more basic, but it's good enough. So let's think about it. We have this tree, and I'm going to create a file here under the folder called happily pace. What should re-render in the ideal world? What should re-render? What must re-render? The parent folder, parent folder itself doesn't change. So the parent folder name, for example, is the same. But the parent folder's children list must re-render because we're changing it. What else must re-render? The size of its parent folder and the size of its parent folder and all the way to the top. And other than that, in the ideal world, nothing must re-render. Right? Let's check that. So I'm going to create one single file and watch the outlines, but I'll do it multiple times so you won't miss it. Oh, 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 oh. Everything re-renders. Let's think about it. In the old implementation with React hooks, that's obvious. The very top level state object is constantly recreated, which means the very top component is constantly re-rendered. So everything re-renders. What's going on here? Who knows? Let me open the file and I'll show you. That would be... Any ideas?
You mean exactly why it re-renders?
Why everything re-renders? Like, yeah.
Re-renders to the top, and then it's all the children of that.
Actually not. Like, we don't mutate the data anymore. We don't change the top level folder object anymore. We don't change its children IDs because we do not add to it. But what changes there? There is something that changes at the top level folder.
The size? Only this size.
That's the size.
Yeah.
That's the size. So look at it. This is folder presentation. We have two usual suspects. So once again, that's the convenience of having some special prefix for signals. There is $size and there is $children IDs. Now $children IDs cannot go anywhere. Like if we change the list of IDs, we need to re-render it. That's fine. But now, because there is this size, and whenever we create any file anywhere in the tree, the size of the root folder inevitably changes. And because we read from that signal for the root folder, we become reactive to it, and we re-render the root folder. Oops. So now I'm going to show you how to fix this. I'm going to only fix this specific issue. There will be more, and they can be fixed in a similar manner. But for the sake of keeping it short and go into after party as soon as possible, I'll just make these changes. So I'm going to put down the mic again, because I can't code with a single hand. But I also try to talk without this thing. So I'm going to move this stuff to a separate component. I'll call it item size. I'll return essentially the same element from it. It needs to accept an item, which can be either a file or a folder, because the logic is now uniform. The item, either file or folder, has the same property called $size. We can read from it. And let's put some typings, so we are a good citizen here. That's Node. That's it. So I hope this makes sense. It's super small component, but what I've forgotten here, thank you. What I've also forgotten here is this. It needs to be reactive to changes to the signal. So we need to subscribe to changes. Now let's use it here in the folder. Where was that? Here. And we can also use it in the file because the logic is the same. It's just file here. OK. So that's a change. Once again, I found a piece of reactivity that can be more fine-grained. We can isolate it. Because we are not subscribing to that signal anymore from the folder presentation itself, the folder presentation component will stop being reactive to it. We've moved it to a different component. Don't take my word. Let's check it. OK. I'll refresh it and regenerate just to make it smaller. So let's create multiple folders. That's valid. Like, first I didn't optimize it, second they all belong to root. And let's create more folders here. You can already notice it. Not everything is outlined. And now let's create a file here, and that's the same. Once again, watch the outlines. Only sizes of the folders up to the top, and then the entire parent folder, which can also be optimized in the same way. So if we look at this, at the diff, that's what it took me. Like it was literally 30 seconds. It was a couple minutes more to understand what needs to be changed. I just moved things around. It's quite natural. And then it only subscribes to whatever we were using inside. So it's quite easy. I could just move the children list from folder to a separate component. And now that would not be re-rendered if only the size changes. So that's it. I also had some slides left in the presentation. Let's see what's there. No, not that. This button. We've seen this, and we've seen some code. Quiz time. Who loves quizzes? Some people love quizzes. So my talk is called Signals Wow. What's in the name? What did I mean? Any ideas?
Oh, the wow signal.
That's right. So that's a wow signal. That happened in 77 and 1977, not 2077, in Ohio. And they were looking for extraterrestrial aliens. And they suddenly noticed that they got this super intensive signal between all these 1s, 2s, 3s, 4s. And the researcher wrote, wow. This became known as wow signal, and it helped funnel lots of money into finding these civilizations. We don't know the result. So that's it. That was the play. Good one. And to final note, first, we are hiring. You can follow the link, or you can talk to me if you want to work on rendering video editors in the browsers with signals. And you can also scan this QR code. Hopefully it leads to the same presentation. So there's a couple of links inside and my email just in case. Thank you very much.
Very cool. Wow.
Thank you.
Questions?
Yeah, thank you for the talk. It's very nice, but I can't get a feeling of like you tried to explain the MobX, basically the whole presentation. And I think you already expected this question, but how does it differ from MobX?
Actually, I didn't because I have forgotten about it 10 years ago.
Because it's exactly the same.
The idea is very similar. And most likely, I cannot tell you how it's different because I think MobX is based on the same idea. So basically, this is a foundation. MobX is a specific library. I've picked a much smaller library, probably much faster too, called Preact Signals. I could have picked MobX. It has this extra flavor and decorators and things like that. But other than that, yeah, I think it's the same idea. I just wanted you to understand the idea. You can use MobX, you can use Jotai, you can use Preact signals, you can use Signia, you can use whole solid.js and forget about React and maybe be happier too. So yeah, but thanks for the question.
Because it's Mobix actually dropped all the decorations in favor of like more native way. And it's also like agnostic of React, so
Yeah.
And it was quite also I was hearing about the signals buzz, but I didn't know it's like this exact thing.
Yeah.
Also.
As I've mentioned, the idea of signals is not new. The spoiler, if you're not going to turn to spreadsheets like Excel, underneath, it's all signals because you react to changes, but only where you need to. It's the same idea from 70s, maybe 60s.
Yeah, thank you.
Thank you.
You described that one of the ways you used it at work, or your team used it at work, was in this specific timeline thing. I was curious how you approached. Do you plan to exchange more of the state management in the entire application on it, or do you think it's pretty comfortable to just use it in one part and not really interact with other things?
Great question. Actually, I have a good answer to it. So our team is experienced with using ZooStand, and ZooStand is a good library. Like, it's bare bones, has everything that it needs to, performant from great team. And we are originally planning to use ZooStand for the entire application state and only signals for this isolated component of timeline. Because for timeline, just to give you the idea, what we do is essentially we've implemented relative positioning for blocks. And now, if you think about it, if you move one block and the rest need to maintain their relative positions, they only move visually, but nothing inside of them changes. And there is also no change to the data other than maybe to the next one or the previous one if you move between them. So that was the first instinct or the first motivation behind using signals. We've used them for this library, implementing just the timeline. We were quite happy about it, and we started integrating the timeline with a very early version of our application. And we realized, because the timeline works with signals, we want certain things on our side on the application to also be in signals. So we started experimenting with ZooStand store with some signals inside, which you can ultimately do because nobody stops you. Sorry. But the more we did that, like over 1 week, we went from we must use ZooStand because everybody knows ZooStand to we don't need ZooStand because we can just model an entire application state with signals. So what we do now is we create services as classes. We start with pure modules, went to classes for testability. Inside there is reactive state with signals, non-reactive state with just props, and domain methods operating on the signals. We never expose writable signals, we just mask all the signals as read-only. So our UI layer only reads from signals and only writes through the domain methods. And we are quite happy. So we may change our decision later, but the thing with our case is that we already know the level of complexity because we are creating version 2 of the same application. Not exactly the same, but very similar. And so far, it looks like it's going to work.
I had another question. You mentioned somewhere in the beginning that it should work with any sort of data, but I think you said that it's like better or more reliable with
primitive values?
Primitives, thank you.
Yeah.
Right. So I was wondering, and maybe that's an implementation specific thing, but if you have some kind of a custom data form, do you have to do anything specific for it to work in these callbacks?
Got it. No. It's not exactly what I said. It's not that it will be less reliable. It can work with anything. You change the value inside, and it reacts to that. It's completely agnostic. The thing that I meant, I can slightly elaborate, is that if you have complex data structures inside of the signals, you still need to immutably recreate them for reactivity to work. Because there is still triple equality sign everywhere, checking if the value has changed, and the value needs to change for it to be detected and propagate the change. So if you like once again, I could model my entire application state inside of a single signal, but that would be of no use because I'll go all the same way of rebuilding the entire structure, which I don't want to do because once again, everything would become reactive to every change. So it's just that because you need to rebuild the structures and you want the changes to be small enough, relevant to only, like you want the propagations, the waves, to be commensurable to the changes that you make. Because of that, it's better if you work with simple things, primitives and arrays most of the case. But if there is something like, let's say, I know, we want to represent a color in a quite complex structure, like a class instance with all the methods to RGB, to OKLCH, and so on and so forth. But if you change the color, you recreate it, fine, you can do that, no problem with it.